how would you start off with 8 and 5 12? What would you do? We have adding, subtracting, fractions, right? What's our rule? What do we have to always have? Common denominator, right? So for the 3 8s, what would you, or I'm sorry, the 8 and the 12, what would our common denominator be?
4.
You gotta think the opposite now. 8 and 12 are playing a role as our factors. So now we're looking at an LCM.
I mean, you couldn't do 12.
8 doesn't go up.
Yeah, but 3, never mind.
Wait, so you're trying to find a low number?
Alright, so what does 8 and 12 have in common that they both go into? Think about this. Okay, when I say factors, you gotta know what I'm talking about. Factor times a factor is a multiple. For the factor of those two. 24, yes. Do you agree that 8, 12 both go into 24? Okay, good. I know we're so used to doing factors and factors. Now it's like, oh, we got to change.
About 24 of that.
Yep. No, you are right. Yeah. Okay. All right. So now let's pick on.
Can I guess what you do? You take the numbers and you just multiply however many times until you get the score, right?
Well, because 8. Well, that's 8 times the what goes into 24 is going to tell you what to multiply 3 by.
8 times.
So 8 times 3 goes into 12, right? So that means the 3 is what I multiply the 3 by,
Yeah, that's what
which is 9. Yep. So 12 times what goes into 24? 2. And then 2 times 5? 10. Very good.
So then it's 19 over.
So 19 over 24. And that looks simplified.
This is easy. Easy peasy.
Don't say that you don't.
What? What?
Then I have to bring it
You can't break up that.
12 goes into 24 2 times. Okay? So if I multiply the bottom times 2 to get to 24, then I have to multiply the top by 2. So 5 is up there, so 5 times 2 then. Okay? All right. What do you think about 15? 30, okay. Looks like we're subtracting on this one. Remember, your denominator is going to tell you your new denominator what to do, right? So 6 times what is 30? 5. So I take my 5 and multiply it by the old numerator to get new numerator. And then 15 times 2 gives me 30, so 2 times 7, 14. What is that, negative 9?
Yeah, negative 9.
Over 30? Does that simplify?
Yeah.
Yes. It goes into both, right? So now 3 tenths. If you do struggle fractions, those calculators back there, they're pretty good. Sometimes not function, but they're pretty good with fraction. Like if you didn't know if you could simplify, put it in and it would simplify for you. Okay. Just because we have 3 terms, anything, you still do the same process. Okay? So I've got 5, 25, and 10. Think 50? Okay. Nope, good. So I'm going to put all this under 1 since I'm converting all of them. Okay, here we go. So 5 times what is 50? And then 10 times 2 is 20. So there's my one. I have addition between that one and the second one. 25 times 2, and then 2 times 3. And then 10 times 5 gives me 50, so 5 times 1. Okay. So what's 6 minus 5? What is that, 21?
Yep.
once you have that common denominator, then you can just mash them together. Makes it nice. Okay. Then we have D. Kind of stepping up a little bit. But the process is just to apply a little more algebraic skills. Okay. So let's 6 and 5. What number do you got? 30. Let's just go ahead and just put this all under 1. Okay. Now, the only difference is that the numerators have expressions instead of just one thing, one number. So we have to sure that when we do that, we're going to be distributing. We'll write it out first. So 6 into 30, how many times? 5. So that means I'm going to take my 5 and I will actually multiply it by my numerator, right? That's what I will be. I'm just writing it out so you can see what we're going to be doing. Then I have addition. And 5 goes into 30 times. So that 6 comes up. And my numerator has x minus 3. So now I'm going to be just. Does that make sense? What we've been doing is just now we're kind of seeing behind the scenes what's happening. All right. So now we're going to distribute. So 5 times x is 5. 5 times 1 is 5. And I'm going to do this same thing to this side. Yeah, a couple of like terms, don't I? Okay. So yep, I've got 11x. I'm leaving every 30 though, because that's my comment. I haven't done anything. Negative 13. So minus 13. And that's it, right? I don't see that we can. Now, if I looked at the 11 and the 30, and that could simplify, I would split the option and simplify it. And then the 13 and 30, nothing can go into it. So I'm just going to leave it together. How's that? Okay. Okay. What? All right. I think mine, but I don't think yours does. So I think I took out some of the questions as far as my answer key goes. Okay. Number 1 is your number 1. All right. What do you notice? I have what operation?
The letters on the bottom.
Okay. What do I have? Subtraction. So in the adding and subtracting world of fraction, must have what? Common denominator, right? Do I have? I do. So what do I get to have the right to do? Right. So I'm going to mesh them together. So here's my common denominator. Here's my subtraction, right? So I have f 5x minus 1. What I f from. All right. Now the only is that this negative, like this term right here, is being subtracted, right? So if you actually think about that, let me write it out. Let me show you. Like this is what's happening. So I have minus that. So everything here is going to change signs. Sense? You don't have to write that step. I'm just letting you see what's going on. Okay? Yeah. When you get about it, then you can definitely be lazy and forget some of these steps. All right, change this. Now, so negative 3x, and then that 4 is also going to be negative. I distributed that negative for 3. And I only did that because I don't have a little room. All right, so now what? I can. So go ahead and simplify them. So the 5x and the 3x give me Positive 2x? Because it's bigger?
Oh, yes.
Right? Okay. It's okay. So positive 2. And then I have a negative 1 and a negative 4. So negative 5. That's right. Minus 5.
That's where I was getting minus.
Okay. One thing we need to still be getting used to is we have to all state the what? Excluded values. That's right. So on then, what can our x not be?
5 and negative 8.
No, look. Remember, you look at the denominator.
Negative 8.
So x cannot be a positive 8. Sorry, totally lied. A negative 8. Totally lied. I seem to be doing a lot of lying today. Totally lied. Okay. I want you to work number 2. Okay? It's just number 1, except we have addition, so I think it's easier. But it's the same process. At least you don't have to worry about the piece of distributing it through. Oh, also, just because we're in this room, like if we do get into your weather drill, whatever, or not really a drill, but in the real thing, we in here, so like we don't go. That's what I went. Yeah, so we're in the inner room, we're good. I don't think anybody comes into our. I didn't see like I had an X up there. I would assume we're good, so nobody comes in here. So just want to get up. All right, your denominator is x minus 5. Okay. So then, with that said, I can squish all of my numerator terms together, and we have addition, so that's nice. Then, once I do that, put them all together up top, I am just going to combine my like terms. And then I'm also going to state my excluded value.
It's a good thing that no one needs to wear wipers.
All right. All right, so you can get on 3.
We all take it home. I do not want to ride the bus. You end up having
Think about the same concept as you're through it, as far as what you're doing and what you notice there. So what do you notice? Denominators are the same still, right? Even though they're in form, they're still the same. So, no, you leave them alone. Yep. Yep, we're just going to leave them alone. We'll only mess with them if we need to, but we're good with the factored form. All right, I have addition. I think that's always a no, right? Because that's not going to change any term. So I'm just going to go ahead and I'm going to rewrite everything. Can I FOIL that first? Yeah, we're just gonna, because I know I can do that one, but I'm just gonna put them together first, and then we'll see. Was that positive 4x and a positive? Let's see what we can get first. So did you get this far? Okay. And we have a positive 7x. And then positive 10. Nice. Those numbers. I'm thinking on the lines of a 5 and a 2. Just saying. Okay.
So then, we can't, or x cannot equal.
I'm done. Right. We know that it cannot be a negative 5. We'll go ahead and write that disclaimer. Negative 5 and a positive 2, right? So there's part of our excluded value, or the piece of that. That numerator be factored. This is kind of like what we did on, what day was that? Monday. It can. Yes, it can. So, yep, I'm picking on 10, and I'm picking 5. So I know if I add those, I get a 7. Multiplying, I get my 10. They're positive, so that's good. So everything is going to be positive. And I can check it and FOIL it if I need to in order to verify that I'm good with the signs. So my 5, what we saw Monday, right? My x plus go away, right? They simplify out. Which is why it was important to go ahead and say our x values, because our 5s is our x plus 5 go away. So our final answer is x plus 2, x minus 2, and don't forget to include your, have 2 excluded values, just the 2, but also the negative 5. I could see the mistake is that you would simplify and you'd get everything and you'd tell me the 2. So make sure you tell me everything before you simplify terms out. How was that one? It's nice when they're common, right? You know they're always not going to be common denominators. So as you can see, what's happening to the next problem. Notice we start out small, okay? All right. I'm going to have to erase this, of course. It's in my way. All right. So I'll give you a hint. Whenever you have different terms, this one's a little tricky because they both, one has 2 x's and that one has an x. So this one needs a 7 and needs another x. Does that make sense? So like 7 is what I want. So that's what they're going to have as far as their common pool, so to speak. Usually you're going to mold them. As far as getting that common denominator. Looking at my high degree, I have an x, so I know that's going to be the common multiple. And then this one has a coefficient, so 7 is going to be part. So this is thought process, okay? On the left-hand side, the x squared and then the denominator, what does it need? It needs to have a 7, right? So because 7x squared is going to be our new denominator, this one needs the 7. We need that 7, so that means that's what we're multiplying the top. So that's 13 now. See how if I simplify that, I would get my 2 over x squared. Okay. And then I have a 7x. So what do I need on that side? I need another x. That's when I'm going to multiply. If I need another here, then I have to multiply that top part by x as well. So you're always mind what that denominator is to that numerator. That's what you're always doing. So my 3x top. So you're always looking. Let me change colors here so you can see it. This is going to be a common practice. Okay. So whatever is missing here with this one, like this one's missing that 7 x squared. That means that's what you multiply by for that new piece right there. So like this one here, like we knew ours was missing an x, that's what we have here. So that's what we multiplied that top part. That's how we got 3x. So if I squish them together in a single term, or just a single, like both of them together as far as the common denominator goes, this is what I get. Can't do anything. What can my x not be? What's my excluded value? Huh? I'm not adding or subtracting down below. What number, if I multiplied it by 7, I'm going to get 0. 0. Right? It's not an additive inverse. It literally multiplies, so it's going to not be 0. This is my final answer. Okay. You can. You can negative 3x and a plus 14. Yeah, it's fine. I would if I was going to go the next step, but I wasn't. I mean, there's nothing to do there, so I just left it. Okay. I'm going to ignore 5 and 6. Just because they already have common denominators. Those are good for you if you want to practice as far as the factoring. But I want to go to number 7 or 8 so you can practice the common denominator form. I'm going to put the answer key to 5 and 6 in here, though. Okay. All right. Because you can see those are the same my denominators are. I'm not going to waste time with those. Scooch it up anymore. All right. So what are we going to do for 7? I've got x minus 4, and then I have x squared minus an x plus 12 in the other one. Let's get it in factored form. Okay. So is this one factor?
Negative 3 and negative 4.
Okay. Let's see. So negative 3 and negative 4. So multiply positive, yes, and then I get a negative 7, yes. Okay. All right. This one only has x minus 4. So what? Here's my numerator here. My numerator here. So what does my common denominator need? I've got x minus 4 on the left. I've got x minus 3 and x minus 4 on the right. So x minus 3 and 4 is my common denominator. Do you agree? Because the only thing that's missing on the left hand is x minus 3. Right? So if I need x minus 3 here, then that means I also have to multiply it by the top part. Does that make sense? So I'm showing the work a little differently in this one just so you can see in a different way. But it's still the same process. Okay? I don't have to do anything to the one. I guess I'm going to have to write it up. To do anything on the right-hand side because it already has its common denominator. So x minus 3, x minus 4. Okay. Blue. All right, now I have negative. I have that going on the right hand side. Now pick on the on the left. So now I'm going to do this piece. This piece here. Okay, that's the piece I'm going to be working with. What do you think we need to do? That piece. Yep, we've got to do our whole factoring, right? So on x minus 3, we need to pull that out. And we need to, on the right-hand side, distribute that negative. So we got a couple of things that we need to be doing in order to get this one simplified. I am showing a lot of extra steps, but I'm wanting you to see from one step to the other. Decide what you're proficient in. Okay? So I've got x first inside, so negative 2x, negative 3. So that's that one when I pull it up. Now I'm going to distribute the negative 1 through. All that's doing is changing my signs inside. Did I lose you there? Let's combine the numerator. Just for space, I'm going to erase some of this when I combine like terms. Do you see my x's? I can get a negative 3x. So I'm going to have this in my numerator. And then I have a negative 4. So I'm going to rewrite it and put the numerator. So x squared minus x plus minus 4. Okay. I'm almost done. We got to pick on 4. I got 2 and 2 and 1 and 4. Does any of those combinations give me a 3? When I pick on 4. So 2 and 2 and 4 and 1. I need to add or subtract 3 out of that. 4 and 1. So if I have 4 and 1, I need my 3 to be negative. So I need the bigger to be negative, and I need my 1 to be positive. I can subtract them. And the reason why I need a 4 negative is because 3 is negative. Now I'm going to rewrite my denominator. Bring it down. I'm almost done. I've got 2 things to do. What are 2 things? I do. Minus 4s are going to go away. What's my other thing I need to do?
You need to find
So before I make the x minus 4s goes away, I need excluded values, right? So before I do this simplifying, let's go ahead and say that x not b. Looks like I got a positive 3 and a positive 4. So now I can go ahead and then get rid of my x minus common factors. And then I'm going to bring the other pieces in. Whew. A good one. More. I literally worked that in. Ready to do the next one? Okay, same thought process. This is our last one, by the way. If you can hang in there. I'm not laughing, I promise. Poor thing, you guys look like deer in headlights. Bless you, goodness. Okay, remember we said that whenever our common denominators are like this, we always know it's the of them, right? So 2x minus 1 and x minus 6. That's what my denominator is going to be. I'm not even thought into it. Now what number was that? Number was a little different because as they were single term, so it was a little bit easier to get those. So these are expressions. So it's always going to be that. All right, now this one here needs 2x minus 1, right? So that means that's what I'm also multiplying the top by. So I'm going to rewrite this so you can see. So minus 5, then I have 2x minus 1. So that was in that term. And then my 2x minus 1 is missing the S6. So that's what I have to top by. So 4x is already there. Okay. Does that make sense? That problem will never change. When you use expressions like that, it won't ever change. So you do them as always your denominator, and then look at each individual one, and you're like, okay, I need to multiply my numerator by the missing term or expression that it needs. Okay, so a little bit of simplifying to do. Seems like I'm going to work backwards on this one too. Now I'm just going to multiply through the 4x, the green part there, and then have negative 10x. Now I'm doing the red, plus 5. My 4x squared stays, and now to bring my negative 24x and negative 10x. What does that give me? Negative 34x, and then the positive 5. Oh. Is that not a factor? Nope, it does not. Well, maybe if I did this, let me see. Then I did a 5. Nope. Still don't get 3. So that's not factorable. So this is actually, we would have to do something else. We're done. So yeah, so like when I was messing with that, it doesn't. So it looks like x cannot be positive 6, and then like on those types, when it had type of expression, a little bit of simplifying. So it looks like I'm going to get 1/2. So it cannot be, x could not be a positive 1/2. How was that?